Last time I was talking about how happy I am with the core mechanics of my game, remember? I was going to focus now on detailing everything around it. Well, I let my girlfriend play what I have, and that turned out to be, let's call it, illuminating. Watching someone else play the game that you yourself have gone through a billion times already always makes for a very healthy change of perspective. It wasn't all bad. I mean, she got through alright, with little difficulty. Actually, far too little difficulty. There were the expected little things like a UI that doesn't make it clear where to click or what to do next, and so on. But also, as I stood there watching, some more fundamental things became so obvious. The card game mechanics are too boring, the gameplay on the map is way too linear, the exploration part falls largely flat because there isn't enough to discover. The layout even encouraged players to walk straight from A to B to C. So I ended up with a long list of homework. You might think that must have been a depressing experience, but on the contrary, I actually felt really excited. In a matter of minutes, all these blind spots had been exposed, and I now had a list of very concrete tasks that would help me create a much better game. So paradoxically, I felt as if I had struck a goldmine. All of this being said, I'm obviously still busy with improving gameplay in a few areas. The card challenges are more interesting already, and I'm working on ways to reduce linearity. Currently it's mostly, find a tool on the map, use it, obtain another tool, use that, and so on. As you have hopefully already noticed, the map view has changed to get away from the nodes connected by edges look. I've also come up with a solution for a storytelling problem that has been bothering me for a long time. Since the player mostly explores the history of the places they visit, these past events are told by historical accounts, monuments, inscriptions, letters and the like. That's all nice, but it started feeling a bit dry. So I came up with what I call spirits of the past. These are immaterial ghostly beings which the player encounters on the map. They have always been around so they can voice their opinions and report on events they witnessed 100 years ago firsthand. The implementation is still very simple, but I have some ideas about giving them character, letting them emote, and even different behaviors. Which brings me to today's technical section. I'd like to explain how I implemented these little guys. It's not rocket science, and I'm using a few Godot features here that you will probably find useful in a lot of situations. In particular, I'll be mentioning sprites with gradient textures, particle systems, and how to use noise functions for randomized movement. Let's dive into it. Here's a little test scene where I put 3 of these things that I call spirits on a ground plane. If we run this, we see them moving around their original positions in a randomized way. Apart from the obvious particle trails, you might also notice that they are pulsing and flickering a bit, and in addition they have slight color shifts. Let's have a look at how all of this works together. I've separated the movement from the rendering of the spirit, so each moving spirit scene here contains a nested scene that in turn holds the visual components. The body of each of these spirits is a simple 3D sprite holding a radial gradient texture. You can create one by choosing New Gradient Texture 2D from this dropdown. To create this disk shape, you need to set the fill settings here to radial, have it emanate from the center outwards. You can then adjust the colors to your liking. If you're using alpha values for transparency as I did here, don't forget to enable transparent here in the flag section. The particles in the scene are coming from this GPU particles 3D node here. I am keeping the number of particles emitted fairly low, I think 8 is even the default, and they only have a lifetime of around 1 second each. The geometry of the particles is specified in the draw passes section here. In this case, each of the particles is a quad mesh. These meshes are all facing in the Z direction. To get round particles instead of quartz, I'm using a small circular texture in the albedo of the material. The material is otherwise unshaded. I've also set the transparency mode to alpha here. All the options for manipulating how particles are emitted and behave over time are sitting in the process material section here. There is actually a lot of stuff in here. It's probably a good idea to just play with the settings and see what happens. Let's just have a look at the things that I touch to get the effect that I want. First of all, the emission shape is by default set to point, which would let the particles emanate from the center of my object, which isn't what I wanted. I wanted them to appear a little distance away from the center. So I set the emission shape to sphere surface with some radius. Next, I didn't want my particles to fall to the ground, so I disabled gravity by setting all these vector components to 0 here. To make the particles move away from the center radially, I simply set the radial velocity here with some randomization. As you see here, the particles are slowing down as they move away from the center just before they disappear. And I actually tried using the damping parameters here, but for some reason they didn't have any effect. So what I'm doing now is using a negative value for radial acceleration. To make the particles fade out towards the end of their lifetime, you can go to the display section, and then there's the color curve subsection, and in there's an alpha curve which you can edit. I'm simply letting the alpha value drop over the second half of the particle's lifetime. Finally, to give the particles a little bit of color variety, I'm setting the hue variation parameters here. And I think that's basically all I have touched in here. Now let's have a look at how I'm making these things move around. The general idea is to have randomized movement on the ground plane, but still have the object be somewhat anchored to its original position. Noise functions are perfect for that. They oscillate randomly but smoothly in a value range that regular is between -1 and 1. The most difficult part of the script is probably figuring out how to configure the noise. There are so many options and parameters. For our purposes here, I use a value type noise, which essentially uses random sample points and interpolates them smoothly. I did write a little noise test application a while ago to understand the effects of the various parameters better. So this is what a noise function looks like when you visualize it as a 2D image. So this is the value type noise function, and I think I had a frequency of 0.2 with 5 octaves. The octaves add some higher frequency distortions to the global smooth value change. Let's look at this with lower frequency again. So this would be like an extremely smooth noise, and when you add more octaves to it, you get higher frequency noise on top of that. In my script, I use a one-dimensional noise function for each axis of movement. It's really the same function, but sampled at different offsets. So for each frame in the process function, I scale the result of the noise function. Remember, this is generally in the range -1 to 1. I scaled it to the range in meters that I want the spirits to cover, and update the position from the result. The current noise function parameter for each axis is then forwarded using the time delta. As the final tip for today, I'd like to show you how I implemented the hue shifts for the sprites. There are some interesting details in there. Here's the script. There is another noise function in here to achieve the flickering effect, and also kind of a sine-based pulse to adjust the scaling. But what I really want to talk about is this part here. Each time an instance of the scene is added to the tree, the existing gradient texture is duplicated and modified in this function here. So the first point to notice is why the duplicate. If you modified the gradient texture directly, you would notice that all of the instances are changed together, because the texture is a shared resource. So we have to make a copy first, change that, and then assign it to the texture property again. I obtain a copy of the colors in the gradient, modify them in a loop, and reassign them to the gradient. One very small detail that I find noteworthy is this in here. So you can actually change the hue of a color just by assigning the .h property. I almost couldn't believe that this actually works without any HSV back and forth conversion functions. It's brilliant. And on the same line here, there's another little gem of a function. fposmod works like modulo, but wraps in both the positive and negative directions. I'm using it here to keep the resulting value in the range 0 to 1 when adding a random negative or positive offset. And that's it for today, a little longer than usual. I hope you found something useful. See you around for the next update. Bye!